Well, everyone, welcome back. It is Prietology Season 4. Wow, already 4 seasons. Today we start Season 4 of Prietology. Talking about this season, we will be talking about geology and earth science. Two mixed into one. Talking about things like, today we're going to talk about the basics of geology. We're going to talk about geography, biomes, weather, and a bunch of other stuff that'll be pretty interesting. So if you haven't seen Prietology before, I recommend stopping this video. Go watch season 1, 2, 3, and 1, 2, and 3 in the playlist right here. Go catch up on some chemistry, physics, and biology that we've done before. Still, sadly, we will not be doing Experiment of the Day. I don't know if we'll be doing Experiment of the Day next season. Sneak peek, we're doing another season. So yeah, I don't know if we'll be doing Experiment of the Day next season. So yeah, might as well talk about the table. Yeah, you see it's a bit different. There's no more plants. I'll just explain some of the stuff on the table. So here we have the textbook that we're using. Bachelor Science is what we usually use. Our old faithful big book of science experiments. A Statue of Liberty, because why not? I just liked it. Yeah, it's a really cool Lego. And a plasma globe. You might have seen it in the first episode ever of Prietology when we talk about noble gases. There's some noble gas in here. And introducing a new thing, an item of the day will be used for Prietology. Today's item of the day, an Earth. We're going to be talking about the Earth and its structure today for the season premiere of Prietology. A new series, video series will be starting soon, but that's for announcements at the end. So yeah, like we usually do, we go over the key terms. Alright, so usually at the beginning of the episode, and today's is the first episode, the basics of geology, usually at the beginning before we start getting into the terms, we review the key terms. A new thing that I'm implementing this season, for every episode, there will not be more than 10 terms, because I remember doing season 3 episode 2, holy mackerel, that took way too long, 20 terms in that one. Well, we have 8 terms only today, so that'll be better. So we have crust, mantle, core, plates, hotspot, earthquake, rocks, and minerals. Let's get started in our brand new season. Alright, here we are, our first term of Prietology. And also one more thing I should mention, we will still be doing fun facts at the end of the term, like we did last season. Crust! Where we are right now, you are sitting on the crust right now. It is the top of Earth's layers that contains all life. If you want to know more about life, check out season 3 of Prietology. It is made of solid rock that contains continents, seabeds, islands, plateaus, mountain ranges, water. We'll talk about a lot of that more in a later episode. It also has mountain ranges that point out of the crust and anti-ranges that point into the mantle, which is a layer below it, like folding paper. Like, hold on really quick. Here, I have a piece of paper, and if I fold it correctly, here we are. These are like the mountain ranges, so as you can see it's in the M shape. So basically the mountains, if you look closely, the mountains are the ones that are pointing up top. The anti-ranges, the mountain ranges are here, the anti-ranges point in the mantle. So if my finger here's the mantle, this is usually how mountain ranges work. It's just contracted plates that are together. So usually the rocks that make up the crust are things like basalt, granite, and sedimentary rocks, which we will get to in a bit. Fun fact, our first fun fact of the year, the crust makes up only 1% of the Earth's volume. All the crust is only 1% of this thing. Pretty cool. Yeah, we only live in a small part of this big world. Alright, our second term of 8, we're already making good progress. The mantle. So basically how we're going to go from the Earth layers down. The mantle is usually considered to be divided into an upper and lower mantle, us living closer to the upper. It's the largest liquid area, and it moves a lot, so it's a churning sea underneath the crust, and it moves the plates, the crust plates, a lot. We'll talk about plates in a bit. More solid rock is at the top of the crust, and it's more liquid near the core, so the upper mantle is usually more solid, more like a Play-Doh almost. It's kind of like a Play-Doh at the top that's very mushy and grainy and rocky. It's still mushy, it's hot. The liquid is like a smoothie. So just imagine a Play-Doh on top of a smoothie. That's a horrible analogy. So yeah, basically that's how it's like. It's Play-Doh-ish at the top and more smoothie-ish at the bottom. The movement of the mantle can cause earthquakes and volcanoes, which we will also talk about in a bit. Volcanoes are considered a type of hotspot, which is also something we'll talk about later. Fun fact about the mantle: the thickness of the mantle is 1,800 miles. So that's like 1,800 miles. That's about, so if the crust is 1% of the mantle, then that means... I can't do math right now. So yeah, 1,800 miles. That is a lot of thickness, a lot of Play-Doh and smoothie. I need to change that analogy later. Alright, our core is literally the core of the Earth. It's the absolute center of the Earth, as far as you can go. It's divided also, like the mantle, into an outer and inner core. The inner core being completely surrounded by an outer core. So like if I put my fist like this, my other hand is the outer and the middle hand's the inner. I need to make better analogies. It's divided, so the liquid core is outer and the solid core is the inner core. So it's like a... I'm going to stop making analogies. You guys can get it. The rotating currents, well, the rotating core is the thing that creates the magnetic field of the Earth. The rotating currents create the magnetic field in the Earth. The magnetic field is direct current, if I remember? Yeah. Magnetic field of the Earth protects us from radiation, cosmic radiation and stuff like that. The core is mostly composed of iron and nickel, which allows for it to be magnetic. You know, iron's magnetic, so a rotating magnet around a metallic outer core makes a magnetic field. It also has nickel, which is also magnetic, but not as magnetic as iron. The fun fact about it, the diameter, since it's a sphere, 2,166 miles. That's a good amount. Alright, we're halfway there. Plates, not as in dinner plates, but tectonic plates, the ones that move about the mantle, pieces of crust that float along the mantle. So basically, like, there's an experiment that some people do. They have milk, I think it's milk, and they put something on top, or water, and then they put like slabs of wood on top of it and see how they collide and stuff like that. So basically they just float around in the crust, just colliding slightly, and you know how the mantle rotates, that's how the crust can move. The colder, denser plates during earthquakes sink into the mantle, and the colder, denser plates are usually at the bottom of the ocean, which are oceanic plates, versus continental crust, which is on the land. So you right now, if you're not at the bottom of the ocean, you are on continental crust right now. Collisions between plates, because plates don't just go smoothly like F1. Like, remember how in Formula 1 when I played, there's collisions all the time. Beat him down the straight! Let's beat him down the straight! Come on! Push me off! No! Ah! There's 4 cars everywhere! Plates are exactly like that, except they're not cars. But there are collisions between them all the time, and those is what we call earthquakes. Those release massive amounts of energy that you feel as a shake. Fun fact, the smallest plate, and yes, there are names for these plates, there are 12? Hold on. Alexa, how many tectonic plates are there?
Are currently 14 major plates and 43 minor or secondary.
So she said 14 major and 30 minor, so 17. 17 plates. And the smallest out of them is the Juan de Fuca plate, which I don't know where that is. I'm going to guess someplace in Central South America. Yeah, alright, let's get into the second half of the season, not of the season, but of the episode. Alright, term number 5 of 8. Let's try saying this fast 10 times. Hotspot, 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 hotspots, hotspots. I can't say it fast. Hotspots! Hotspots and hotspots. Hotspots galore throughout the Earth. There are places in the crust where the mantle is unusually hot. Pieces of mantle, like little holes in the crust where the mantle can come up and heat the surface. And usually, like, remember what we said, the top of the mantle is like Play-Doh. The bottom is a smoothie. So that smoothie somehow is able to get through the Play-Doh layer and into the crust. They can make geysers, which are erupting water, hot springs, just boiling hot water that you should never touch, and the most of all, volcanoes. That's where the biggest ones are. All of them, hot elements from the Earth coming up and spewing for pressure and heat from the mantle, which, like I said, is unusually hot where it is. That's a great hotspot. Magma can arise from the mantle in the form of volcanoes, and the magma flows out of the volcano in the form of lava. So when magma is inside the earth, it's called, when magma is inside the earth, it's called magma, and when it's outside being spewed out onto the crust, that is lava. Usually volcanoes erupt because of pressure and heat, a lot of other factors. If you watch physics in the Prietology season 2, you'll understand everything about physics. Well, not everything, but a good amount. Still a bit unknown about how they form, really. Scientists are still figuring out the theory of tectonic plates. Still a lot of mysteries to be found. Yeah, that's really a lot of mysteries that still yet to be solved in the scientific world. Fun fact, the number of known global hotspots, so hotspots all over the world, like major ones, 50. Only 50. Yellowstone being one of them, volcanoes. Really, those are a lot of main ones, and usually the volcanoes are located around an area in the Pacific called the Ring of Fire, which is also a place where a lot of earthquakes occur. Alright, a massive shake of the earth. In earthquakes, which are term number 6, lots of shaking in the earth, a collision of, give me some things to collide. A collision. You see a collision like this? A collision of two plates at an area called a fault line. There are fault lines that are basically the borders between the crust. So basically, let's say you have, let me give a good analogy. I think this analogy could actually work. Hold on. Let's say this is our Earth. These, so let's draw the continents really quick. I'm going to draw them on my side and I'll switch them for you guys. Alright, I've drawn our Earth. It's upside down for you guys at the moment. There you go. That's a really rough interpretation of the Earth. But the fault lines, let me draw it with a different thing. These would be our fault lines. Cracks in the Earth. I don't know the specific plates, but literally cracks between the plates. So like, imagine just like getting a pane of glass, like a sheet of glass, and just smashing it. Creates cracks everywhere. These, I don't know the exact like location of the plates. These are our plates along the entire surface of the Earth, like that. So basically that's really how the Earth is organized, but not an exact interpretation, but that's really kind of how it's organized into different plates. Alright, let's get back to the board. So if we look at our map again, we'll see that like I said, the Earth is divided into different fault lines that separate the plates, and those are the plates that float along the mantle. So there's a difference in plates. So there's two types of plates really. There's oceanic and continental. The denser, like I said, with plates, the denser oceanic plates will go under the continental crust into the mantle, just sink in there. When the collision between plates, I need something else now for analogy. Hold on. I have two playing cards, so say this is our plates. They're coming towards each other, and you see, it's a bit hard to tell, but I'll go like this so you can see it. When plates collide like this, so this is our continental, this is our oceanic. The continental will be going under, the oceanic will be going under, and the continental will just slide on top of it like that. Two continental crusts that collide can make something that we see everywhere, mountain ranges or mountains. So they would go like this, and they would bend. It's a bit hard to do with playing cards. They go like this, and they would bend upward like that, protruding into the sky with the anti-ranges that we saw in our folded paper example, that the anti-ranges go into the mantle. Yeah, so basically oceanic versus continental, the oceanic will sink. Continental versus continental, they will rise. Oceanic versus oceanic, I think those will make the undersea mountain ranges, I think. So yeah, that's really it. The friction and energy is what you feel when there's an earthquake. So the friction and energy of two plates sliding against each other, creating immense pressure and energy and friction, all being released in the form of an earthquake. That's a lot of energy. And under earthquakes in the ocean, so let's say we have oceanic versus oceanic crust. Those are what we know as tsunamis, which are giant ocean waves that can go into the land and make chaos. Fun fact, the most earthquake-common country, Japan. Like I said, they sit in a region of the earth called the Ring of Fire, which is a place where a lot of volcanoes and earthquake and a lot of the fault lines are located there. Alright, we got 2 more terms to go, and these are some good ones. Alright, we've been doing all this talk about crust and mantle and plates, but we've never talked about what they're really made of. Rocks! Rocks are everywhere! They are the things that make up the crust. Considering that we live on the crust, there would be an abundance of rocks everywhere. There are 3 types: igneous, sedimentary, and metamorphic. Those are the 3 main types of rocks that you will, actually the 3 types of rocks that you will find everywhere. Igneous rocks are cooled magma. Remember, we will learn what magma is. It's lava that is spewed out from, well, it's cooled lava, which is magma spewed out from volcanoes onto the crust. And those are usually come in the form of basalt and granite. I don't know if I showed you this, but I had this little miner little thing. They have different rocks and minerals on them. I don't know which one's which, but usually these ones are igneous or sedimentary or metamorphic. Sedimentary rocks are ones that have been layers that are made of layers of sediment, so like sands or dusts or something, or like little tiny crushed up rocks. They are pressurized over a lot of time made into a new rock, so basically just shoved together and forced to exist with each other. These usually come in the form of limestone and shale, which are 2 common sedimentary rocks you would find. And the final is metamorphic, which is a little different, a little more harder to understand. It's when igneous or sedimentary rocks are heated, like igneous or sedimentary rocks, and pressurized, so they can be heated or pressurized to create a new rock. So basically, if you heat up a sedimentary rock, it can become a metamorphic. If you pressurize an igneous, it can become a metamorphic. If you heat up an igneous, it becomes a metamorphic. If you pressurize a sedimentary, it can become a metamorphic. For a lot of other different things, it creates a new rock, and these usually come in the form of slates and marbles. So that heat and pressure is what really is the creator of all rocks and the variation in the type. Fun fact, there's a rock called let me see if I can say it right. Feldspar, Feldspar, now you can see it better, makes up 60% of the crust. A lot of the other ones is just other things that are found in the crust, like I said, basalt, granite, limestone, shale, rocks, slate, and marble. Alright, we got one final term to end the first episode. Alright, here we are, the final term of Season 4, Episode 1, the basics of geology. If rocks didn't interest you enough, minerals will. They're the beauties of the earth. They can be extracted from rocks, or sometimes they just live in solitude, like they are not present in rocks. But usually, if you ever seen it, like here we go, here's an image. This is an example of a geode, which is some minerals found inside rocks. So that's how some minerals can be present inside rocks. Valuable metals can be extracted from mineral ores to make things like, like gold, silver, lead, iron, a bunch of other valuable metals that are super valuable in today's society. Minerals can also be in the form of crystals, which is usually how you see them. So if you put the geode picture back up, you'll see that's some crystal in there. And if we go back to my miner statue, you'll see there's actually some crystal in here. We have some purple crystal. I don't know what it is, but it's kind of falling apart at the moment. But yeah, it would be an example of a mineral. These are an example of a rock. As you can see, different appearances. Minerals have more of a lust, have more of a shine. They can be in the form of crystals, like you know some of these crystals. Diamond, quartz, emerald, gypsum. There's a lot of other really cool ones out there. I don't know what that one is. I'll look that one up. Jade. That's another cool one. Those are usually very valuable and usually come with conspicuous consumption and stuff like that. Fun facts. The world's largest crystal, the biggest one, is 55 tons of gypsum. That's a lot. A gypsum crystal, that is 55 tons. Wow. I'm not going to do the clapping thing anymore because we're getting a hang of Prietology. We're already 4 seasons in. Alright, we are done with the episode. So usually at the end of an episode we do announcements. So let's just get on to announcements. We got some pretty important ones. Look at this. Whenever I bring my hand close to it, there's a lot more spikes and stuff like that. Alright, announcements. Season 4, off to a bang. Geology is a great topic to discuss. Season 1, episode 1, check. Some announcements. Gaming videos, you might not see them for a while. I've been doing a lot of gaming recently. It's a really tiring video to make, so you might see a gap in gaming videos. Coming soon, 2022 summer vacation. That we are going on vacation again, and it is coming very soon. More details about that. I might start gaming videos after we come back from vacation, but that is still to be determined. We will figure that out. A brand new video series. It's not gaming. It's like you and me having a conversation. I call it F1 Review. I will be doing my own personal view and commentary of some Formula 1 races. I'm going to start with the first 5 that have already happened this season, which happen to be the first 5 races that will be happening this season, which is the Bahrain Grand Prix, Saudi Arabia, Australia, Emilia-Romagna, and Miami. I'll be doing my personal thing. So if you're a Formula 1 fan, join in. It'll be pretty fun. First episode is expected to be May 14th. Alright, I think that's it. The next episode will be about geography. We're getting into some of the physical Earth science. So now that we talked about what's making up the Earth, let's talk about what's around the Earth. How as humans, like you and me, distinguish the different land features. So latitude, longitude, tropics, landforms, plateaus, continents, and much more. Stay tuned for that. That will be next month, I think. So yeah, that's really it. Thanks for watching, guys. I will see you for the next episode of Prietology, and coming soon on May 14th, the first video of Formula 1 review. See ya. Oh, I forgot to say remote. Whoops, I should. Hello everyone, welcome back to Dprieto TV. We are back with Prietology Season 4. We are in Episode 2. Sorry for the long delay in videos. As you see, I've been on vacation for like about 3 weeks, and I uploaded the vacation video. So yeah, we are back to the normal upload of things, and we are back with Prietology. Today's topic, like I mentioned in previous episode about 3 months ago, go check it out up there. The geography game. We're talking about geography today, and that's why today's item of the day, it's a world map, the countries of the world. We'll be talking about latitude, longitude, time zones, equators, tropics, how the light of the sun alters, how the light of the sun affects time and stuff like that. So yeah, we'll go into that. Like I said during the vacation video, there will be no F1 review. Didn't really work out. Episode 3 and future videos will be discussed at the end of the video. So yeah, we haven't done this in a while, so yeah, I'm excited to be back. Let's go over key terms. So yeah, this episode is actually going to be quite short. We're on episode 2 of, I think, 6? Yeah, we only got 4 key terms today, but we're going to do a little demonstration of my little demonstration of how the sun's light affects things like seasons, latitude, longitude. Anyway, we'll get into that later. And usually what I'm going to try to do for every episode now in this season, I'm going to try to do a demonstration per video. So stay tuned for that. Yeah, only 4 terms today. Longitude, latitude, I have to remember to say those right. Longitude, latitude, equator, and tropics. Yeah, let's begin. Where did I put the remote? Oh, there it is. Alright, our first term. It's the first of our, as I call it, the Earth twin. I don't know. First of all, longitude. It's 24 vertical lines on the Earth. Does it have it on this map? No. 24 vertical lines on the Earth called meridians that are measuring the globe east and west. They can help really calculate the distance of the Earth, which is like the cumulative distance, so essentially the size. If you add up the space between 24 meridians, 24 pieces of one whole, essentially, you can calculate the distance of the Earth. You just got to know the segments. There is something called the prime meridian, which is the prime meridian that runs exactly through the middle of something called Greenwich, which you've probably seen as GMT time, Greenwich Mean Time. It's at 0 degrees, neither east nor west. It's exactly in the middle of the Earth, the exact middle of the time, and anything to the west, so it would be
So like if this is the Greenwich Mean Time, then starting this way it would be 10 degrees west, 20 degrees, 30 degrees west. And so this side it'd be 10 degrees, 20, 30 until you make a full 180 degrees. 90 degrees would be the other side of the prime meridian, and then getting all the way 100 degrees to the other side of the earth would again be the prime meridian. East, like I said, is time going forward, and west is time going backwards. So I'm currently in Arizona in the United States, in Phoenix. Time is backwards by, currently right now where I'm at is 4:14 p.m. It's currently, I think it's at 11, it's about 11 p.m. So currently, if we do the math, how far behind are we? We are 5, 6, 7, we are 6 behind Greenwich Mean Time. So how that would usually be written, it'd be -6, and then so it'd be, if this is the prime meridian, it'd be -1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 12, and then the other side would be +1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, that's essentially how they work. Fun facts! This was actually measured first. The first accurate measurement of this was made by John Harrison in 1737. Wow, that's pretty good for that time to measure the meridians. And find out how like time is altered, so like daylight savings times and all that stuff. Yeah. Let's move on to the second term. Alright, second term. Holy mac, we're already halfway through. We're approaching halfway through. This one has some latitude. Get it? Yeah, that's a really bad joke. Latitude. It's got some attitude, so let's talk about it. Latitude is 5 horizontal lines compared to the 24 that make up the parallels to make up the meridians. That's why there's 24 hours in a day, because there's 24 meridians. There's only 5 latitude lines called parallels. These are measured in degrees, but this time instead of going east and west, it goes north and south. The most famous parallel that you guys probably know is called the equator. We'll talk about that in a bit. These really define the climate zones of the Earth. So the farther you get, so the highest of the lines is divided evenly into this, by the way. The highest of the lines is going to be colder, then hotter, 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 hotter until you get to the equator. Longest line, like I said, is the equator. Other zones between the lines are really called the climate zones, which are things like the tropics are between the equators, and the lines above and below them. And then the top lines are the circles. That's why I've heard of something called like the Arctic Circle or the Antarctic Circle, because those are the bottom of the latitude lines. We'll talk about more about latitude and longitude this episode. So yeah, and then there's temperate zones between the equator and the tropics. So between, let's say we have our 5 lines here. So here's the Arctic, one of the tropics, equator, tropic, and then circle. So like things between like the equator and the tropic and the lower tropic zone, that'd be like a hotter climate. But between the tropic and the Antarctic Circle, which is one, that's more of a temperate climate. That's the same with the higher tropic and the Arctic Circle. Like those are places like New York that has more temperate climate. Canada, Northeast US, those have more temperate and more foresty climate. Fun fact, the latitude of New York City is, let's see if I wrote this down right, 40 degrees 47 minutes north. So essentially 47 degrees north, that is almost 90 degrees, which would be, so let's say this is our latitude line of the equator. This right here would be 90 degrees, right? This would be 90 degrees, so it's somewhere about here. Kind of accurate. That was really inaccurate, but you get the idea. It's more of like in the temperate forested areas, which would make sense since it's in a higher parallel. The parallels do have names, so we'll go over that in a bit. Let's move on to the next term. Before we move on to the next term, I want to do the demonstration to see how like the sun's heat, the sun's light affects like things like latitude, longitude. So yeah, let's dim the lights. As you can see, it's kind of dark right now. I'm going to get my flashlight. So I don't know if you can see my Earth, but now this is going to represent my sun. I don't know if you can see that clearly, but there you go. There you see how it kind of like, so let me make it brighter. Oh no, can I make it brighter? Oop, that's too bright. There you go. Essentially, that's going to represent my sun. So you see like, the Earth is obviously tilted to like act as seasons, but you see as it rotates around this part, obviously that is facing the darker side is much darker. As you can see, the part that is more to that side, and that's how the meridians are formed. The meridians are essentially according to like what's evenly dark and what's evenly bright. So essentially the parts that are farther in time are going to be more towards the night side. The parts that are more behind are going to be more towards the light side. I don't know if I'm rotating it the right way, But yeah, and as you can see also, the parts that are not as bright, so you see the part that is much brighter is the part with the equator. Now I'm talking about latitude. All the heat is concentrated in the equator, and the farther you go to the north or the south, the colder it'll get by the Antarctic and Arctic circles. So yeah, this is really how like the light of the Earth kind of like affects like the latitude and longitude of the Earth. It's all based on the sun. All right, let's turn the lights back on. All right, I hope that was a cool demonstration. Dominators with the equators. That was a really bad segue, but whatever. Equator. Up next is the middle line of the Earth, the exact 0 degree latitude. 0 degree latitude of latitude. It's, how much is it longitude? Longitude, well, it really just depends where you are on the equator. You're essentially going to be north of the equator, and longitude south of the equator. It depends where you are. The hottest parts of the equator are in the middle, and then when you get to both hemispheres, the hemispheres are the things the equator separates. So northern is north of the equator, south is south of the equator. The hottest parts, so like the deserts and like the Atacama Desert in South America, the Sahara, in Africa, the like Malaysian islands, Indonesian islands, they pass through that, Papua New Guinea, all those like Asian, like Southeast Asian islands, more tropical climates, are located more near the equator. It's farther than any pole from any other equator, from any other parallel, so farther than the tropics, than the circle. Well, the circles are closer to the poles. We'll talk about poles in a little bit. Oh, I forgot to put a fun fact on the thing. Anyway, we'll talk about, actually there's a 5th fun fact on there. So yeah, we'll talk about that in a bit. The equator essentially is the farthest from each pole. The poles are at the top of the Earth. We'll talk about that later. Fun fact about the equator, our grand line or glorious line. The number of countries it crosses, 13. Let's see how many I can name. I'll put the list up here. These are all the countries that it crosses. Is Ecuador on the list? I think so. Equatorial Guinea. Venezuela? Maybe. Malaysia? Maybe. Not the US. Kenya? I think so. Anyway, there's a lot of them as you can see. So yeah, penultimate term now since we actually have 5 terms. Hey, you want to know a hot topic? The tropics. It is term number 4. I've been mentioning this a lot, so let's just start talking about it. There are different lines of parallels. There's the parallels, I'm looking at my map. Yeah, the ones just above and just below the equator. So the 2nd and the 4th of the parallel lines of the latitude. They're called Cancer, not as in like the disease, but as in the zodiac sign. So Cancer, the crab, as the northern one. So the one closest to like the US. And Capricorn is the one below the equator, which is Capricorn the goat or ram. No, Aries is the ram. Capricorn, I think, is the goat. I think, yeah. Cancer is north, Capricorn is south. The tropics between these two, the tropics are the regions between Cancer and Capricorn, so that's why they're called tropics. So the top one is known as the Tropic of Cancer, and the bottom one is known as the Tropic of Capricorn. Those ones are only known to have 2 seasons. So basically, right now, I am currently, to look at my map, yes, I am right now in the region of the Tropic of Cancer. We really only have 2 seasons here in the U.S. We really just have a summer and a winter. That's really it. It just gets hot and a little less hot. That's really also the bottom in like places like, I'm looking at my map down here. Places like Argentina or Chile or Paraguay, they really only have like a summer and a bit-ish of a winter. So yeah, and places like below the Arctic Circle and above the Cancer have 4 seasons, like places like New York, Canada, Alaska. They have more seasonal things. While places, and also like below the Antarctic Circle, the places above the Antarctic Circle and above and below the Tropic of Capricorn have more of a 4 seasons climate. Like, looking at my map, like southern Chile, and like the Falkland Islands have more of a 4 seasons, like summer, winter, fall, and spring. Fun fact: the distance between the 2 tropics, Cancer and Capricorn, 3,000 miles. That is a lot. All right, we got one final term to go. Poles. We've talked about the equator, the things above them. Now we talk about the ends of the Earth. Literally, the top and bottom of the Earth. The poles, the top and bottom parallels. The Antarctic is at the bottom, Antarctica. The Arctic Circle is at the top, near the Arctic Ocean. North, south. Very cold and icy climates, as many people know, due to a lack of sunlight. Like we saw in my demo, I'll put the clip up here really quick. You didn't see much sunlight hitting the top or the bottom because, yeah, not much sunlight hits those places, which makes it more colder. Both contain the polar regions of just the Arctic Circle, which is just ice, so like icebergs and ice sheets and ice caps just everywhere you can find. And the Antarctic Circle is more of a continent, so there's more, it's snowy, it's a desert, I think actually, it's classified as a desert. So there's more of a mountain regions. Obviously there's snow and ice and icebergs everywhere. But there's also like mountains covered in snow and stuff like that. Yeah. Both are at 90 degrees latitude. So if we think of our latitude line, this is our equator. If we go down all the way, it's 90 degrees south. If we go back to our equator and we go all the way up, it's 90 degrees north. Fun fact, the coldest, guess which one's the coldest? I'll give you a bit. The coldest is the South Pole, actually. Coldest is Antarctica, because if you think about it, if the tilt of the Earth is like this, if it's kind of like 23.5 degrees, I think, the Arctic Circle is going to face a little more sun than the Antarctic, because if it rotates like this, the Antarctic Circle barely gets any heat, and it's going to be more colder since it's near the bottom. More light is going to be able to reach the top region more than the Antarctic region, which is the South Pole. Yeah, let's annotate the map a bit just to get some more familiar use of both longitude and latitudes. Alright, so now that we've learned about all the longitude, latitude, equator, tropics, and poles, let's start annotating. So the longitude lines, let me find Greenwich. It's in the UK. It's about here. So I'm typing right here. So it's basically just a vertical line going that way, and a vertical line going that way. And then there's 12 on this. It's evenly divided into 24 essentially pieces. Now let's get to the more important stuff. Let's get to the latitude. As you can find, let's find our 5 lines. So here would be the equator. Ecuador, Colombia, Brazil. Doesn't pass through Venezuela. This is the equator. This is the equator. This is our Tropic of Capricorn. Below this, so like in this region between this and this is more of a tropical climate, more of just a 2 seasons. So places like Brazil, Southern Africa, like Angola, Namibia, Australia, like I said, the Indonesian islands, more tropical Asian islands, more of those like more of like a tropical like 2 season climate. Below that we have our Antarctic Circle. This is more of a 4 seasons climate, so like places like New Zealand and Argentina, South Africa, and then really the Falkland Islands. And below that is just ice and snow, so just draw snowfall. That's ice and snow. And now we go above the equator, we see that we have the Tropic of Cancer. This is also another 2 seasons thing, so places like Saudi Arabia, India, Mexico, Mauritania, Niger, Sudan, Yemen. Those are more places, more of like a 2 climate thing. You can essentially pull in Arizona into that place because I'm right here. No, that's not Arizona. Never mind. Arizona's right there. That is essentially Arizona, more of a deserty climate, only 2 seasons. And then let us find the Arctic Circle is right here. As you can see, between this and the Arctic Circle, it's more of a temperate climate. So places like Canada, New York, Kazakhstan, Europe essentially is a temperate forested climate. China. And then above you see places like Svalbard, Greenland, northern Canada, Russia. Those are more of an Arctic climate, which is up here. This is all Arctic Circle. As you can see, it says Arctic Ocean right there. This is all ice and snow and icebergs as far as the eye can see. Whew. Alright, let's do our announcements. Alright, announcements. These are a bit outdated since I made this presentation a while ago, but let's see what we can do. Reminder, there will be no F1 review. That will not happen due to complications. Next episode, let me check my calendar. Next episode is going to be on August 20th, which I will discuss a bit later. And then after that, I might just start going back to like doing gaming every other weekend, every other video. So like you would do Prietology gaming, and it goes on and on. Yeah, the first travel video, all that stuff. Yeah, it's a bit a while ago. Okay, episode 3 of I think 6 will be about geography again, but we're not doing latitude, longitude, and a bunch of other stuff again. We're doing essentially what would be part 2. I'm doing this back to back. It's not back-to-back like week, but next video will be in 2 weeks. It'll be about landforms, so things like continents, mountains, rivers, plateaus. I have to look at the presentation again. So yeah, continents, plateaus, we're going to go into landforms, how they affect climate and stuff like that. Get excited for that in 2 weeks on August 20th. Not August 20th, but August 21st. Yes, I'm looking at my F1 calendar. August 21st, expect it. So yeah, everyone, thanks for watching. I'll see you in 2 weeks for Prietology Season 4, Episode 3. See ya. I'll see you in 2 weeks. Well, hello everyone, welcome back to Dprieto TV. We are already on episode 3 of season 4 of Prietology, and what a good episode we got today. The landlubbers, we're talking about geography essentially, part 2 that I said. So things like landforms, mountains, plateaus, islands, coasts. We got a lot of stuff happening. Exciting video will be coming on September 3rd, which is the next video, so get excited for that. That'll be interesting. So yeah, let's waste no more time. Let's go over the key terms. So yeah, our key terms, we got more than 5. We had 5 last time. I'm going this side. Where's my marker? There it is. We only got 7 today, not much, but it's going to be an exciting one. I'll tell you that. We even have our demonstration, like I said, will be happening every episode. So let's get down to business. We have continent, mountain range, plateaus, rift valley, peninsula, island, and coast. So yeah, let's get started. Well, for our first term, there's a pretty big chance that you're on one of these big landmasses. It's continents. There are 7 of them in the world: Africa, Antarctica, Asia, Australia, Europe, North America, and South America in alphabetical order if you want them. They are the biggest land masses on Earth. So if you remember let me get my map. If you remember the map that we used last episode, go check it out over here. Here's our map. We see our 7 land masses. Yeah, that's pretty much it. These land masses can be moved around by tectonic plates, and a lot in this episode is going to reference some things from the first episode from when we did it. So tectonic plates, remember those plates that jostle and move around on the Earth's crust? They move around and jostle up the continents to make fault lines and earthquakes and stuff like that. These continents, like places like South America are full of them, Asia sometimes, they're full of rocks and minerals that can be used for resources like steel, for conspicuous consumption, for stuff like precious stuff like diamonds and jewels. So yeah, a lot of these continents come chock full with resources. That's why it's pretty valuable to stay on a continent than an island. Fun fact. Let's go back to our map. Europe, which is right here. North America, which is also right here. And South America. Oh boy. And South America. All those continents are able to fit inside Asia. That tells you how big Asia is. It's massive. It can fit Europe, North America, and South America in it. But you might be asking, hey, but isn't North America like super big? It's like almost as big as... That's because like usually sometimes globes extend and overextend the dimensions of some continents because it's hard to make a flat image from a sphere. Yeah, that's pretty much the reason why you see some countries like Greenland. Like if we go back to our map, you see that Greenland's almost the size of Africa. No, it's not the case. It's pretty small compared to Africa. So yeah, second term, let's go. Well, here's something with some age. It's mountain ranges. We already talked about mountain ranges a little bit in the first episode when we talked about the basics of geology. They're the collision zones between plates that divides the continent. So if we go back to our map, we'll be using the map a lot if you haven't seen yet. Places like the Ural Mountains, which are in Russia, like literally about here. Those are that's where 2 plates collide. Essentially, the borders between both continents, where the crust just folds up like that, and then it creates mountain ranges. The taller and more jagged mountain ranges are going to be younger. So basically, if something like more tall, if it's taller like that, it's more cracked and jagged and weird looking, it's going to be younger. So basically that means like recently some plates collided and made a mountain going like that. I don't have the paper with me, but let me see if I can find it to explain the third concept. I also found this. Remember this from the first episode when we drew the collision lines? The fault lines, rather. Yeah, so basically it's kind of like continents and borders. So yeah, what I was going to say is, remember when we talked about anti-ranges when we talked about mountains? Remember, so my example of, let me put the clip up here. Here's the clip. You remember the folding paper thing where the anti-ranges poke into the mantle, so it's kind of like an accordion effect. The top goes up front, the other one dives into the mantle, into the searing lava of the mantle, and yeah. Basically, it's kind of like an accordion effect with ranges, with the mountain ranges, and anti-range. Fun fact, Mount McKinley, which I think is in Alaska, yes. Mount McKinley is the highest mountain in North America, if you did not know that, located in Alaska. It stands at a remarkable 20,320 feet. I don't know what that is in kilometers, so yeah. Let's move on to the third term. All right, you want to learn some French? Well, here we go. We have our term plateau. You've probably heard this before. It's an elevated flat landform. When I say flat, I mean incredibly flat. Usually grassy grasslands at the top, so flat grasslands. Similar to a mountain, similar to a hill. You basically kind of combine the both. To be classified as a plateau, it has to be at least 1,500 feet or 1,500 feet. So Mount McKinley, like we said before, that's not a plateau. It's way too high, 20 times higher than this. Elevated landform, it consists of a top, a flat top, and steep sides going like, so essentially, imagine a trapezoid. It's got a flat top like that and steep sides like that. Yeah, that's kind of like a plateau. Has some grasslands and stuff on top. There are usually 3 types of plateaus. There's not specific terminology, but there's just ways to like classify what plateau is, and that's how they're made. There's one plateau which is made from mountain ranges, so like fallen mountain ranges, stuff like collisions of plates. There's one made from crust, which is like kind of like also like I said, the collision of plates. The first one is more of like deteriorated mountain ranges that just wear out over time. The second one is more of the collision of plates that doesn't make a tall mountain, just kind of goes like that. It doesn't make too tall of a mountain. And the third one is from erosion, from like lava flows and stuff like that that come away and erase lava. They come away and then just melt away the plateau and mountain into a plateau. Wind erosion, water erosion, different types of erosion. We'll talk about erosion later in the series. Yeah, it's basically kind of what plateaus are. Fun fact, they're also called tablelands. That kind of makes sense. Tables are flat, it's a landform. So yeah, if it's a tableland, it's nice and flat. So like this table that all this stuff is on right now. The table that has all the stuff right now, this could be considered a plateau if it was a naturally occurring landform, which is not. Try saying this term fast 4 times. Rift Valley, Rift Valley, Rift Valley, Rift Valley. Sounds like I'm saying Rift Valley, but it's Rift Valley. Rift valleys are pretty interesting. They're giant cracks in the earth caused by the pulling of crust. Like you remember, tectonic activity pulling crust apart, and it makes a flat floor, kind of like our plateaus, and a steep wall. So basically it's kind of like an inverted plateau. If we take our trapezoid, we turn it upside down, it's a flat floor and then steep tops going like that up. So yeah, that's what rift valleys are. There are lots of activity inside rift valleys, like volcanoes, like a lot of geological activity, since the crust is being pulling apart closer to the mantle, closer to the heat. Hot spots, remember what we learned in the first episode, can occur here. This can be things like volcanoes, hot springs, and stuff like that. A lot of geological activity. The largest in the world, like in the world that you can find, are not located on land, on our landforms. They're located on the sea, on the seabed. So places like the abyss, giant cracks. I think the Mariana Trench is a great rift valley, and then with Challenger Deep being the deepest point of the earth. Yeah, those are giant rift valleys, and then you can go super, super, super deep, and it gets super dark inside. So yeah, that's basically kind of what rift valleys are. Fun fact, the length of the Great Rift Valley, which I think is the largest in the world on land, it's located in Africa, I think. Yeah, near Kenya and Tanzania. 3,700 miles. All right, we are here at our 5th term. We can find these all over the world. It's peninsulas. Peninsulas are actually interesting. There's the Yucatan Peninsula, Florida Peninsula, Arabian, Iberian. There's a ton of peninsulas out there. Korean Peninsula. It's a piece of land that essentially kind of sticks out like a sore thumb. So if I have my hand like this, say this is the shoreline, this, like say like I have my fist like this, essentially this, like kind of sticking out like this would be the peninsula. So imagine Florida. Here, I'll put up a map of the United States right there. We have Florida right there, kind of sticks out to the side. That is a peninsula. It sticks out from the shoreline. It is almost completely surrounded by water. And the water that touches it is usually from giant landforms of water, so like oceans and seas. It has to be almost completely surrounded by water, otherwise it would be another landform, which we will talk about in a bit. It has to be classified as a peninsula, it has to be longer than it is wide. So imagine Florida. If it was, like Florida's pretty long and like long length, and it's not super wide, it's kind of thin. Or places like the Iberian Peninsula are much longer than they are wide. The Yucatan is longer than it is wide. Korea, yes. Iberian, yes. The Arabian, yes. Yeah, so essentially to be classified as a peninsula, it has to be longer than it is wide. Fun fact, I'll give you a wow. Guess the world's longest peninsula. Alright, It's the Arabian Peninsula. Let's go back to our map. The Arabian Peninsula is literally lives up to its name. It includes Saudi Arabia, Iraq, Yemen, Oman. It's by, if you look at our map here, I'll get the map a little closer. It's by right there. Right there with that little blue spot that says Saudi Arabia. That is our Arabian Peninsula. It has the Red Sea, Persian Gulf right by it in between. So the Red Sea is the part touching Africa, and the Persian Gulf is the part touching Asia and places like Iran right next to it. And then to the south, it's the Arabian Sea. Alright, we only got 2 more terms to go. Let's get to our penultimate term. Alright, we are at our penultimate term. We are technically on an island, but yeah, let's talk about islands. Islands are essentially can be found in any body of water. Australia, Hawaii, I'm looking at my map right now. The Malaysian Islands, Madagascar, Maldives, Sri Lanka, Iceland, England, Japan. It's everywhere across the world. They are very, well, they're not small landforms, but they can basically almost be in any type of body of water. They have to be completely surrounded by water, because remember what a peninsula is, almost completely surrounded by water. Islands have to be completely to be considered an island, and it can't be big as like a continent, because continents are not islands. Islands have to be like the size of Greenland or Hawaii or Madagascar to be considered island. They can make multiple islands, so a chain of islands, like, let's go back to our map. The Caribbean islands, or places like Indonesia that are multiple islands, those are called archipelagos, which are basically chains of islands, a group of islands. So like Hawaii, that is an archipelago. Malaysia, that is an archipelago. What else do we got? Caribbean, like places like the Bahamas, that's an archipelago. Maldives are an archipelago. Like I said, it has to be surrounded by water. Rivers and canals, they do not count. They do not count as a big enough body of water to make an island. Like if you find a rock, or if you find like a big rock in the middle of a river, that does not count as an island. It has to be completely surrounded by something like an ocean, sea, gulf, bay, or whatever. Fun fact, the smallest island in the world, it's not one of the Micronesian islands, it's not Hawaii, it's not Madagascar, Iceland, Greenland, Japan. It's a rock, literally, it's called Bishop Rock. It's in the UK, it's like the size of the table, so like, do you see this? Like, you see the table where we're doing our filming and stuff like that? Oh, microphone. Like, the table where we're doing our filming, it's about the size of that. It's very small. Alright? So yeah, Bishop Rock in the UK, the smallest island in the world. Yeah, we got 1 more term to go, and this one's actually pretty interesting. We're just going to go into a lot of stuff what's leading up to in the next episode. This term right here doesn't really like to boast, but it can. It's a coast. It's one of the most interesting terms. Our final term of this episode, coasts. You see them everywhere around the world. They are the border between land and water, the world of the land and terra and terrestrial things, and the underwater world of the seas and the ocean. So, the border between all our continents, every single landform in the entire world, this guy's in all of them. The coast. It can resist multiple types of erosion. So places like water erosion from storms and hurricanes sweeping onto the island, it can resist all that. It can resist wind erosion, like I said, from hurricanes and sea storms. It can resist a lot of stuff, but in the result of that, the minerals and rocks that are found at the coast are very fine. So like sand has to resist a lot of punching and stuff like that from wind and water erosion. That's why I see sand very fine, or places like, yeah, a lot of sand. Like if you go to the coast, you'll see a lot of sand. Those are fine rock made from erosion. We'll talk about erosion a little later in the next episode. I don't want to spoil too much. Coasts can come in many forms. They can go in any forms around the world. Fjords, beaches, coves, bays. Beaches are obviously the big one they've seen. So like beaches like Venice Beach in California, Long Beach, California as well. Beaches in Mexico, Asia. Those are all coasts. It's specifically the border between land and water. A border between land and a river, that's not a beach. It has to be a big landform. Fun fact, the East Yorkshire coast in the United Kingdom is one of the fastest eroding coasts in the world. It's taking a big beating right now. Well, it has been taking a big beating. It's eroding fast. But that's why usually in like places like England, you see like the coast is about, let's say the sea is about here. This is like sea level, so imagine this is the sea. The coast is like on a cliff. Like that. That's how big it's like. That's how big it is because of erosion and things like that. All right, let's do our demo just to demonstrate our different landforms. It's going to be an interesting one. We're using kinetic sand. Okay, time for our demonstration. As you see, I have a package of kinetic sand. I'm going to open it. This will help represent our landforms and like the different activity that can be found around them, like quakes, like earthquakes, tectonic plates, like we talked about, continents, coasts, plateaus, and landforms. All right. Our first term was a continent, so essentially, this is our big landmass. This is like, let's say this is North America or somewhere like that. This is our giant landmass. Mountain ranges are essentially, let's make up two plates. This is our essentially, let's say these are our plates. Essentially, is when plates collide like that. And as you can see, when I collide them like that, it builds up. This is our mountain range, and it can build up like that and that and that. And then essentially, that's how plates are formed. It's very not the greatest example, but you kind of get the idea. Plateaus, essentially, they can be built up. Remember, from our three ways they can be built up. They can be made of like mountain ranges. So like, let's get our mountain range back. If our mountain range is a road, so let's take a piece off. Let's say it erodes like that. There you see, it's a little flatter. That would be our plateau. It can be made from crust. So let's get a bit of sand. So essentially, we can have our plateaus made from that. There you see, it's a little flat. It's not the greatest example. And then lava erosion. I obviously can't get lava right here, right now, because I don't want to burn my hands off. So yeah. Rift valleys, remember that we learned, are giant cracks in the earth. So if we get let's make our landform again. Essentially, they can be born. I'm going to take the map off because the map is making it slide around. Our rift valleys can be made from the pulling of crust. So let me see if I can pull it properly. There you see it like that. And it can make giant fissures, well, giant cracks in the earth. So a rift valley would kind of be like a giant crack in the earth, so kind of like a canyon-ish, but it's not a canyon because those are built from like erosion and stuff. They are built from tectonic plates, so these plates pulling each other apart like that, these are the things that make a rift valley. Our final one, peninsula, so let's make our peninsula. So let's say this is our landmass. I'm going to take a bit of sand. This, let's say, is our landmass. Let's make North America. Let's make the U.S. This might take me a while to make the U.S. Alright, that's my best interpretation of the U.S. Now let's make Florida. Florida would essentially go right there. This is our peninsula. As you can see, it could stick out massively. And essentially, it has to be longer than it is wide to be classified as a peninsula. Our second to last one, islands. So let's say these are our islands. The blue, obviously, is our water. So essentially, these are our islands. These are the ones that are completely surrounded by water. So these would be considered islands. And the coasts, as you can see, it's more frayed and a little fragile around the coast. So you can see like there, it's a little like more, not like solid completely. Like you see it falling from my hand. These would be our coasts. They're more beat up and naturally occurring from erosion. So yeah, those are the ones that usually like take a lot of the beating and on the border of the land and the water. All right, let's get on to announcements. Whew. All right, cleaned up the sand. Let's get on to announcements. We got some good ones. Which one do I want to do first? Let's do the first one first. It's been a long while since I started this channel. Since the summer of 2019, I made the Made that video, our first vacation. I filmed it on my phone. Actually, let's give you behind the scenes. Let's do a little story time. Or do I want to say that for the video? Yeah, I'll say it for the video. Speaking of the video, the next video on September 3rd is the 3-year anniversary video of Dprieto TV. It's been 3 years since I've started this channel. Look where it's evolved. We have Prietology, we have gaming, we have travel, we have reviews, we have vlogs, we have specials. A ton of stuff has evolved over these last 3 years, and I want to thank you guys for being a part of every single moment of it for the past 3 years. You've gotten me really excited, and you've got a lot of videos planned for the future. So yeah, September 3rd. Don't miss it. It might be a premiere. I'm still thinking about it. So yeah, stay tuned for that. Our next episode is essentially going to be... Oh, right. I have to do a drum roll. Next episode... Oh boy, I don't want to knock over my plasma glove. It's cost a lot of money. Geography. Again, we're doing Geography Part 3. It's our last Geography part, coming on September 17th. But now we've talked about geography like latitude, longitude last episode. Today we talked about landforms. Water forms are next. Oceans, rivers, seas, delta. And we get to talk about the mystical force behind all these land and water forms. Erosion. That is the main playing character behind all this stuff. So get excited, coming September 17th. So yeah, everyone, thanks for watching. I'll see you in 2 weeks for the 3-year anniversary video. See ya. Well, hello everyone, welcome back to Dprieto TV, and we are back with Prietology. We got a good episode today. It's our final of our geography episodes, part 3 of our geography, here in season 4, where we're talking about earth science thus far. Episode 4, we're already halfway through this season. The waterworks is our episode today, of water forms, rivers, deltas, oceans, lakes. We got a good amount of stuff to talk about today. At the end of the video, I'm going to give more details about the upcoming fall break vacation, which is coming on for you guys. It will be published on October 15th. More details about that at the end of the video. So yeah, let's waste no more time. Let's go over the key terms. Alright, we got a good amount of episodes today. Let me move to this side. We got 9 of them today. We're just at the limit. Remember, for every episode now on forwards for Prietology, the max is going to be 10 terms per episode. We got 9 of them today. Water, river, delta, lake, ocean, tide, glacier, ice cap, and the god of all of our geography stuff that we've been talking about thus far, erosion. That is going to be a big topic to cover today. So yeah, let's begin. I also forgot to mention when I was reviewing the terms, we have a demo today, and that's going to be like in the middle of our episode somewhat. So yeah, get excited for that. Before we talk about any of these terms, we got to talk about what water forms and the waterworks are made of. They're made of water, the crucial element of life. It controls all life processes. Every single form of life in the universe needs water. It covers 70% of the earth, so that includes oceans, seas, rivers, lakes, deltas, ice caps, glaciers. All the stuff we're going to talk about today. 70% of the earth is water, and that can be determined into like salt water and fresh water. In liquid form, it can make rivers and oceans, and in solid forms, it can make glaciers and ice caps. In gas form, we can make clouds and winds, clouds and thunderstorms, and basically all the weather that governs our planet. Fun fact about water, Earth has, let's see if I'm making this right, 326 million cubic miles of water. So imagine a 1 by 1 by 1 mile cube. So a cube that's 1 mile this way, 1 mile that way, and 1 mile up. There's 326.28 million of those cubes in the world. That is how much water there is in the world. Alright, let's move on to the second term. I would say this term is as important as your liver. That is not an empty threat. It's just because it's so important. This is going to be a crucial term in our episode today. So we have river. Rivers are pathways made by water that erode the land around them. So imagine little pathways of water going down mountains from rain, the rain that comes down the mountains, a water cycle. Yeah, we're going to talk about the water cycle later in the season. They erode the path they go on. So wherever path they go on, they're breaking up the rock and basically transporting it. And the rivers, with that eroded rock, transport sediment along its current. So all that, if you see like little pebbles and little like tiny little rocks floating along rivers, those are sediments that can be crucial to some forms of life. Require sediments. Basically, these are just kind of like eroded rock that are carried by the river. During these rivers, small little rivers called rivulets can join a main river down its path downhill, and then rivers can also start waterfalls. So if a river runs off a cliff, then it's called a waterfall. And the rivulets are the ones that join the main river and essentially make up one big river, so kind of like an inverse delta. We'll talk about delta in a bit. Fun fact about rivers and rivulets: about 0.0001, about 1/10,000% of the Earth's water is in rivers. That's how much other water is concentrated in oceans and seas. And the sky sometimes, because sometimes the sky, yes, all those clouds that are right above you right now, those are made of water. We'll talk about clouds later in another episode. Term number 3, and this also goes along with river. I said we'd talk about it in a bit. Well, here it is, deltas. These are made up of one or more rivers, and these also, essentially, they're muddy little islands between rivers. So if a river basically kind of like, it branches off into multiple rivers like a tree. And like I said, they're separated by muddy islands, and they're essentially different channels of rivers. There are 2 types of deltas that we need to know. Arcuate, which is a more triangular shape. So imagine our river here, and let's say my hand is the delta. Basically, I'm going to go like that and separate it into multiple pathways into more of a triangular shape. The other type is called bird's foot. It's not super splitting. It doesn't split as much. It kind of goes into little crevices. We'll show you in the demo that we're going to do in a bit. So yeah, arcuate and bird's foot, those are the ones that we need to know. These are made from soft sediment that rivers carry down a main body of water. So when sediment piles up, like I said, these are also made from rivers that carry too much sediment. So when sediment piles up in a river, you have delta, the water can't go for the piled up sediment, it goes around and then you make a delta, and then multiple piles of sediment make multiple multiple deltas, and you have a main delta coming from a river. Then they split off into multiple channels. Fun fact about delta, the largest in the world is the Ganges Delta in India, made from the Ganges River in India as well, and there's multiple rivers I think in India as well. Yeah. 40,540 square miles. That's a lot. That is a lot of square miles. Basically, like I said, a 1 by 1 square mile, that's a lot. And also thinking about it, it's kind of like multiple pathways, so basically all the pathways are 40,000 square miles. Hey, you awake? Because you need to be, for this next term, it's lake. A body of water that is completely surrounded by land. If you remember last episode, we talked about peninsula, which is a body of land completely surrounded by water. Essentially, this is the same. It's a body of water completely surrounded by land. That is a lake. It can be the main body of water that rivers go to or come from in rivers. So rivers either come from or go to lakes. So basically, if water runs down from a lake, you got a river. If a river runs to a lake, then you also got a lake. It's going to the lake. These can either be salt or freshwater. So you either got saltwater lakes or freshwater lakes. Some animals can't survive in freshwater lakes, and some animals can't survive in saltwater. Usually they're very calm. They're very calm. Not many storms on them. The stormy ones are the oceans, and we'll talk about why oceans are stormy next in I think next episode. Yeah, and usually these underground lakes, and yes, there are lakes underground, they are called aquifers. Aquifers are essentially giant holes in the ground, like giant caves that are flooded to make a lake. So basically it's flooded on all sides. It's covered with land on all sides. While, like, let's say we have a lake here on the earth, on land in pure sunlight, it's surrounded by land like this, but caves are surrounded by lands in all directions. But the aquifers are surrounded by land in all directions. Fun fact, the Dead Sea is not a sea, it's a lake, and it is the saltiest in the world. It is completely surrounded by land, which classifies it as a lake. Same with also another place called the Sea of Galilee. Not actually a sea, it's a giant lake, but it's considered a lake because it's completely surrounded by land. Dead Sea, saltiest in the world. You can float in it easy if you weigh a lot, you can still float in it. That's how much salt is in. Alright, you want to know what the commotion is in the world? It usually comes from oceans. They contain 97% of Earth's water. That is a staggering amount. All the other Earth's water is located in rivers, lakes, deltas, ice caps, glaciers, and the one we just learned about, aquifers. All that contains 3% of the Earth's water, but the rest comes from our 5 oceans. The Pacific, the Atlantic, the Indian, the Arctic, and the usually forgotten one that no one remembers, the Southern Ocean. The 5 oceans of the world. A lot of these weather patterns, like rain, hurricanes, clouds, fronts, I'll talk about that later in the season. They come from the ocean, and if you think about the names Pacific, Pacific means like it's peaceful. Paci is like the root for the word peace, so it's the peaceful ocean. The Atlantic Ocean is essentially the opposite of the Pacific. It ain't so peaceful. All the storms and hurricanes, if you think about it, hurricanes usually come from the Atlantic. You never usually hear of hurricanes coming from the Pacific. They come from the Atlantic, through the Caribbean, and then to places like Florida and Mexico. Fun fact, the smallest ocean in the world, actually, if you remember, the biggest ocean in the world is Pacific. It's essentially almost half of the world. The smallest one is the Arctic. It's not the Southern, because literally the Southern encompasses all of Antarctica. It's the entire circumference of Antarctica. Arctic is usually kind of just Russia and Canada. That's it. It's not usually surrounding entire continent. It's a little bit. It's just Russia and Canada, really, that the Arctic Ocean surrounds. Alright, let's do our demo, and then we'll keep going on our terms. Alright, so we have the kinetic sand again for our demo, and yeah. First, I'm going to make a riverbed. If you remember what a riverbed is, well, I didn't talk about what a riverbed is. It's basically the land where a river is formed, so all that eroded material, that makes up the riverbed. I'm going to make our river. Well, actually, let's make the river like this. Let's make it not too wide. Here we have our river. It's a crack. It is essentially like a pathway of water. As you can see, the land right by the river is more eroded. It's more broken up and all that stuff. Like this stuff, sand, well, it's not actual kinetic sand, but sand like this can be found usually at the bottom of a river, more sediment and broken up like that. Deltas are, remember, river channels that are like broken up. So remember, we have two types of deltas. So let me make our river a little more smaller. And remember, let's make our river actually a little more wider. Remember what a delta is. It's pieces of sediment. So let's say we have a delta. This is our sediment that breaks up. And now, as you see, we already have two types of rivers. We have sediment that goes like that. We already have two rivers formed. And then those sediments can be broken up into more. So it can go like that. Like they can be broken up into smaller rivers. And smaller rivers like that. See, they get broken up. And usually, remember, we have two types, arcuate and bird's foot. Arcuate ones, let's say the sand is the shape of our river. Arcuate ones are usually a bit wider, but then go into more of a triangular shape at the bottom. So we have our river here, and it spreads out more like that, like that, like that. As you see, each sand pathway that I'm making, those are kind of like more channels. So as you see, it's more triangular shaped, while a bird's foot would be more smaller, but would be wider, would be longer, but it would be smaller. So let me remake our river. Let's say our sand represents the river itself. It's more longer. As you can see, it's more longer. And it has smaller deltas like this. It's shaped like a bird's foot. Guess why it's called bird's foot? And as you can see, it kind of reminds me, like when I think of it, it kind of reminds me of like a webbed foot. So yeah, it's kind of like that. Okay, let's make our lake. Alright, so we have our landform. Let's take a bit out. So we have our lake here, and remember, a lake is land completely surrounded by water, and you see that the eroded land, usually by the coast, as we learned what a coast is last time, is usually more eroded, even though a lake is more calm. And yeah, that's it. Alright, let's go back to our terms. We are on our 6th term, so let's go back to the lesson. Alright, we are at term number 6. Hope you like the demo. Tide. This one's a little more complex. It's movement of water that is altered by the moon's gravity. So if you heard the rumors, well, some people say it's like fake or like it's not real. But like, hey, the moon alters the Earth's gravity, makes the waves, it makes the tide go round. It actually does. The moon's gravity, I don't know if you can see it, but the moon's gravity is not an actual moon, has influence on our Earth. The gravity of it messes with the oceans and makes the tides. At night, water is dragged towards the moon, so the tide is higher. The tide is higher towards the Earth because the moon is shining directly on the Earth. When the moon and the sun are on the same side of the Earth, the gravitational pull is double, resulting in something called a spring tide. Double lows, which basically means like they're neither on the same side, those are called neap tides. Neap and spring, basically double high, the tides are double high, or the neap tides, or the tides are double low. Basically, they're almost non-existent versus literally flash floods and who knows what the heck. Usually these tides affect the waves on like the shores and stuff, weather patterns. Tide is a massive influence on water and weather patterns. We'll talk about weather patterns later in the season. Fun fact, the Mediterranean Sea, remember it's not completely surrounded by water, and the Caribbean Sea, which is in the Americas, they almost have no tide. If you look at videos of them, they're usually very calm. The Mediterranean has no really major storm systems that go through there every year. The Caribbean does. Those are called hurricanes. And if you've seen the water of the Caribbean, it's usually very clear, very, very serene. It's usually super clear, the Caribbean water, if you've been there. Oh boy, the Atlantic Caribbean area, the Yucatan Peninsula water, it is incredibly clear. I recommend going to see it. Alright, we got 3 more terms to go. Alright, we are almost done. Now we've talked about some of the liquid water forms. Let's talk about some of our solid water forms. The first of them, glacier. Glaciers are U-shaped ice carvings inside mountains. So if you ever seen places like, usually Scandinavia has them, so like Norway, Sweden, Finland, giant carvings of ice in rocks that fill the mountains. So basically it fills crevices inside the mountains, and you have glaciers. It usually starts when snow fills up a valley, like an empty valley, and it compacts into ice. It compacts over a long time with weather patterns and stuff. As I said multiple times, we'll talk about weather in a later season, in a later episode. We'll talk about it in a later episode. So essentially, it's compacted ice. It starts sliding down the valley, carving out even more rock, making even more U-shaped like this. It's kind of like imagine like a bowl, like a U-shaped bowl like this, or a half-open cylinder, and you pour sand into it. That's kind of like what it is. It's just filled with snow, and it makes a glacier. Fun fact, the fastest moving glacier in the world, I don't know where it is or what it's called, it moves 367 feet a day. That is a lot. And usually right now with all this climate change and global warming going on, these glaciers are melting at a rapid rate. Basically all these U-shaped carved rock phenomenon, cool looking things, they're going away because of climate change. So yeah, let's solve climate change, people. We got our penultimate term coming up. Alright, we have our penultimate term, and I'll tell you, this one is no cap. Ice caps. Ice sheets that freeze over liquid water. So it's kind of like what we've been talking about. Solid plus liquid. You got an ice cap. Liquid water underneath and a thin sheet of ice. Ice caps. They freeze in the winter, so usually in places like the Arctic, subarctic, and Antarctica. They freeze in the winter and then melt in the summer back into water. Global warming unfortunately contributes to the melting of these ice caps, which is something we're going to talk about next episode, so get ready for that. With increasing global warming, a lot of these ice caps are melting more rapidly, and sometimes they don't really freeze that much in the winter. They melt more rapidly in the summer. Fun fact about these ice caps, they hold over 98%! More than 98% of the world's fresh water. And these ice caps are usually over oceans. So when these ice caps melt, you're wasting almost fresh water only to be let out into salt water, essentially ruining the fresh water. So yeah, that's why melting ice caps are a big concern, because those contain a lot of fresh water. And some of the animals that live in the ice caps, in the ice cap regions, can't usually live in fresh water, and well, they die. Alright. We got one more term to go, and it's a good one. Oh boy, we got an excellent term to close out the episode. We have talked about it. We have mentioned it for the past 3 episodes, and we've talked about longitude, latitude, landforms, and now we finally get to talk about, to wrap up our geography portion of the season, erosion. It breaks up the land and shapes it. Water, wind erosion. Sometimes geological erosion from lava flows. Erosion of time, like when things wear out over time. Water, wind erosion, I've already said that already. It breaks up the land, shapes it the way we have. The coasts are shaped like they are. Plateaus are shaped like they are. Mountains are shaped what they are. Volcanoes, lava flows, rivers, deltas, oceans, tides, glaciers, ice caps. All of that. Rivers and water forms and land forms all contribute to erosion. Everything we've talked about all comes back to this. Yeah, erosion. That's erosion for you. It breaks up the land, shapes it, and how we usually have our Earth, how our Earth is shaped and our continent, that is because of erosion. Fun fact, the easiest rocks to erode, limestone, which is kind of fragile. It's a little fragile rock. I forget what it is on the Mohs scale. And mudstone. It kind of ends in their name. Mud is soft, and so it's easier to erode. It's like dried mud. So yeah, it's kind of more easier to erode than something like diamond. Well, you can't erode diamond. You need another diamond to break a diamond, but you get the point. Alright, let's go to our announcements. We got some good ones today. It's about the travel video coming soon. Alright, lesson finished. I hope you enjoyed the demo. It was a cool one. Alright, let's get into announcements. Next episode, which is going to be on, I think, November-ish or near the end of October. It is the penultimate episode, the second to last episode of Season 4. Wow. We're already almost done with another season of Prietology. Yeah, we're almost done with that, and that will be the penultimate episode of Season 4. More details about that in a little bit. The 2022 fall break vacation is coming soon. Next week is the last video. The next video I will make will be the last video before the vacation video, and it will be Turmoil number 3. We're playing Turmoil again. We are back with gaming, coming out October 2nd, so get excited for that. We'll be traveling to New York, Albany, and Boston in the northeast of the U.S. We're going there for the first time. We are traveling from October 6th to the 12th. So probably like I did for the summer vacation, I'll upload some shorts, probably about like 2 or 3 maybe, about what we're doing in Albany and Boston, maybe some cool sights. So that's going to be uploaded then. The video itself, it's not going to be a premiere this time. The 2022 fall break vacation will be uploaded on October 15th. It is usually a Saturday, and usually I upload on Sundays, but this time it will upload on a Saturday on October 15th. So don't forget that. Vacation video on October 15th. Next video, like I said, will be turmoil number 2, the last video before the vacation. Alright, now concerning back to Prietology, the next episode will be about weather. We are done with geography. We are talking about weather now. The water cycle, clouds, precipitation, hail, thunderstorms, tornadoes, seasons, climate change, greenhouse effects. We got a lot to talk about. That's probably going to come after the vacation video, so near the end of October-ish, maybe October 20s-ish. Yeah, expect Prietology season 4, episode 5, all about weather and weather forms and how they affect our geography landforms that we've talked about so much. Well, thanks for watching, guys. I will see you for turmoil number 3 on October 22nd in 2 weeks. So yeah, thanks for watching, everyone. See ya.
Well, everyone, happy holidays. Welcome back to Dprieto TV. We are, like I said, we're finally in the holiday season, the best time of the year. It's December. We got a little bit left to go, and we also got a little bit left to go in Prietology Season 4. We are on Episode 5 today, the wacky world of weather. We're talking about climate, weather, the water cycle, fronts, seasons, precipitation, wind. We're talking about a good bunch of stuff today. We have some announcements at the end. Unfortunately, we don't have an experiment of the day today, or a demo, so yeah. We won't have one for the rest of the season, because the next episode, which I'll reveal at the end of the video, it's kind of hard to do an experiment of, so yeah, these next 2 episodes, because we can't really experiment with weather. And also, this is the penultimate episode of Season 4, the second to last episode. The next episode, coming at the beginning of next year, is the final episode of Season 4 of Prietology before we move into Season 5. Well, let's waste no more time. Let's go over the key terms. Well, here in our penultimate episode of the Wacky World of Weather, we got 10 terms today. We're at the max amount of terms now, like I said at the beginning of the season. 10 terms today. We got a good amount of stuff to talk about today. We got the atmosphere, weather, climate, front, seasons, water cycle, precipitation, wind, clouds, and the greenhouse effect. Well, let's get started on our first term. Alright, here we are in our first term. Before we start talking about weather or climate or anything besides that, we got to go over atmosphere, one of our most important factors of anything today. It separates the Earth from space, so essentially it's like the border between Earth, here and land, the sky, and the seas, and space, where there's no sky, seas, and people, and you could die or freeze to death. So this is essentially keeping us from dying. 5 layers, I'll list them over here. The troposphere, the stratosphere, the mesosphere, the thermosphere, and the exosphere. There you go, the 5 layers. It blocks the sun's radiation, it blocks the heat, it keeps the earth warm. It had the ozone layer over here. It blocks the earth's radiation from getting in, and it's in the stratosphere. The ozone is in the stratosphere, which is the second to lowest layer, just above the troposphere. And the ozone essentially blocks the radiation, all this stuff that we don't want coming here on Earth. Fun fact, the Kármán line marks the boundary for the atmosphere. So from here up all the way to the sky, 62 miles. That is a lot of miles. 62 miles from here all the way to space. It's a lot of, yeah. Geez, 62 miles. That would take a while to get there for a rocket ship even. Alright, let's get to our next term. Essentially what we're basing this entire episode off of. Weather. It is the source of precipitation, wind, natural disaster, climate, fronts. Well, actually not climate. Winds, clouds. It's a source of all the geological stuff here on Earth. That's why we're focusing so much of it into this episode. Is a source of precipitation, like I said. It's also can be a main force of erosion, so wind erosion, water erosion. We talked about that last episode when we talked about the waterworks. It occurs mostly in the lower atmosphere, in the troposphere, which is the lowest one. Yeah, weather occurs in the troposphere, which is the lowest layer of the atmosphere. That tells you how big the atmosphere is compared to that.
that if it's 62 miles and the troposphere is way up in the sky, you got a lot of atmosphere. And it's usually influenced by pressure changes. That is the driving force of weather. Changes in pressure, which we will talk about in a bit. Fun fact, the hottest temperature ever recorded by weather, and usually weather contributes to temperature, the hottest temperature ever recorded on Earth, 136 degrees Fahrenheit. That is burning hot. Even here in Phoenix, we get to like 100, usually in the summers like 110 here in Phoenix. 136, I can't imagine that. That's like deadly choking. By the way, this is recorded in Libya, which is in North Africa. Alright, here we have our next term. These next two terms, weather and climate, they're very similar to each other, but climate is really kind of like the governing body of weather. It's a measure of the average weather in an area. So we're kind of going back to our geography a bit when we talk about climate. Climate's the average weather in an area. So like if one has more precipitation than the other, if one's more dry, if one's more wet, it's more predictable than weather. So weather is usually the result of what you have. Climate is the expected, weather is the result. So climate is like, oh, the climate is very rainy here, and weather's like, okay, it actually rained. That's the expected result. Climate's like the conditions that it's in. It is dependent on latitude, terrain type, height above sea level, etc. It's a bunch of other stuff. But really, like, latitude is what's really, so if like you're higher up the earth or lower down the earth, so like if you're in the middle of the earth, the equator, you're going to have more rainy, more dry, but if you're high up in the earth, like the North Pole, it's going to be much colder. Height above sea level, I'm guessing that's about pressure, so like I said, weather's influenced by pressure. With being at higher sea level, there's less pressure, less vapor pressure for that. Climate exists in zones, called climate zones, and the tropics, and there are 5 types of climate zones. There's 6 actually, now that I look at my notes. There are 6 types of climate zones: tropical, monsoon, dry, warm, cool, and cold. And essentially those are all over the earth. So like tropical ones are more near the equator and near the tropics, and the more cooler, drier ones are near the poles, hot and dry like in the deserts near the upper top of the equator, up the higher tropic near the North Pole. Yeah, alright. Fun fact, the hottest 30 years on record, which is kind of like a predictable weather, 1970 to 2000, and probably when we get to 2030, geez, I think it'll probably be more considering with all this climate change stuff going on. Alright, let's get to the next term. Here's also another interesting one to do with weather. Some of these are going to do with weather, probably because we're talking about weather. Front, one interesting term we have here. It's the indication of arriving weather. So if it starts getting cold somewhere, you could tell like, oh, there's weather arriving. If it is windy on a day, new type of weather is going to start arriving. It's the division of air in the atmosphere based on density and temperature. So the hotter, like they say, hot air rises. The hotter air is going to be more towards the top of the atmosphere, the colder air to the bottom. If those 2 types of air collide, then you get nasty weather. Like tornadoes. Tornadoes are made from warm, moist air colliding with cold, dry air. You get those together, usually occurs in the Midwest, you can get a tornado. There are 2 types. There are warm fronts and cold fronts. Let's put a picture right here. Right there. There we see a picture of a front chart, so like the weather in a coming area. The lines with the blue triangles, that indicates a cold front, and the line with the red like semicircles is the one that indicates warm front. And usually you see those in like news broadcasts and like weather shows and stuff like that. The changing between the type of air types makes weather, and like I said, the collision between these 2 types of air types can indicate like bad weather is incoming. Warm air can be led by cold air and vice versa. So like if more cold air is going into an area, you know the weather's going to become much colder. The front is essentially like an indication, essentially like, hey, this is what's coming. That's a front. Fun fact, it was discovered by, I'm probably going to butcher this name, V and J Berknes. I'm going to guess it's Dutch or German? I don't know. Oh well. Here's a term with some meaning. It's seasons. Seasons, essentially, you've seen them everywhere. You know the seasons. You experience them every year. Right now in the Northern Hemisphere in the winter. They follow each other in a cycle, not like the tropics. The tropics are not a cycle. Those are based on climate, like we saw. They follow each other in a cycle. You got your spring, you got your summer, you got your autumn or fall, and the winter. Right now we're in the Northern Hemisphere. We are in the winter. We'll talk about hemisphere and how they influence a bit. It is caused by the tilted axis of the Earth, which we saw. I think I did a demo in the second episode of the season when we talk about longitude and latitude. Yeah, we saw that like the tilted axis can like different variance in temperature. And it's caused by the tilted axis of the Earth. Like I said, it's 23.5 degrees if you did not know that. The Earth is tilted. Half of the year, the north hemisphere will be facing towards the sun, more tilted towards the sun. And the other half of the year, the southern hemisphere is tilted away from the sun. And that is what causes the seasons. Right now, us in the northern hemisphere, we are in the winter. It is a bit cold outside. Not too cold outside because we live in Arizona. It's a desert. But people down right now in the southern hemisphere, below the equator, right now are in summer. Like places like Brazil or Australia or South Africa, those places are in the middle of their summer right now. So yeah, that tilted Earth axis is the one that caused the difference in seasons. So next season, when it's spring, they'll be in fall. Essentially, that kind of like they're 2 seasons behind, or we're 2 seasons ahead. At the equator, there are many rainy and dry seasons instead. And so mostly like in that area, like I said, between the tropics, they're rainy and dry seasons instead of like the normal like fall, winter, spring, summer thing. Fun fact: the Antarctic and the Arctic, they have 24 hours of sunshine in the summer. That is a lot because literally where they are during the summertime. Yeah, during the summertime, so let's say we're in the North Pole and we're in the summertime. We think about it, the North Pole is directly above. It doesn't face away from the sun or go away. It's exactly in the middle. So you're just spinning like this. The Earth would just be spinning like this forever. So you just face the sun the entire time. So yeah, like people who live in like places like Alaska, they experience that stuff because they're pretty high up above the tropics and near the poles. Alright, the water cycle. I'm pretty sure you've heard this before in school, but let's see what we can learn about it. The water cycle is essentially, it's fueled by sunshine. It is the creator of all types of precipitation. It is fueled by sunshine. There's 3 phases, but the sunshine is really the main cause of it. It evaporates the water, which is the first phase, called evaporation. Evaporates the water and it vaporizes, condensing into water vapor. Condensation is when the water vapor cools and condenses into clouds, and those are the things that you see in the sky almost every day. And the last one, precipitation, which we'll talk about in a bit. That's a special phase. Precipitation is when those water clouds have too much water in them, and it's released into the sky and down into land and creates precipitation like hail, snow, sleet, and rain. And yeah, this is really a lot. And like I said, fueled by sunshine, all that thermal energy from the sun coming into the water, vaporizing it, exciting the molecules, and then look, vaporizes into the sky. Fun fact, the year's water molecule in the ocean right now, 3,200 times like a usual molecule will go through a water cycle in a year. 3,200 times. That is a lot for even just a little individual molecule. And think about the billions and billions of billions and billions of molecules that we have out in the oceans all over the world. Alright, we talked about this when we talked about the water cycle for a bit. Well, the most important phase, I would say, precipitation, moisture falling from the sky. Saying it like that makes it sound like some sort of fantasy thing. But yeah, literally, moisture falling from the sky can be in the form, usually there's 4 main forms: rain, which we see everywhere; snow, not everywhere; hail, really only in extreme cases; and sleet, which is also in really extreme cases. Rain, your liquid form of water; snow, your solid form of water coming down in little fragments, snowflakes. Hail, which is like bigger, like more like stuff you would see in tornadoes and intense lightning storm, blocks of ice falling onto the ground. And sleet, which is like a mushy like sludge of water and snow combined at the same time. It's rain and snow combined at the same time and coming down. That's like, it's like also another one of those like really extreme cases as well. The vital part of weather. It is incredibly vital to weather. Without precipitation, there probably wouldn't be weather because there's no water cycle. And the last phase of the water cycle. So precipitation is incredibly crucial for that, and water in general. Humidity is when water, humidity is when the clouds or the water vapor stays at that water vapor state and descends and descends onto the earth, creating, like you would see, fog and stuff like that. When that water vapor comes into the earth and then creates more of like a sticky texture, usually found more in like the oceans where more vaporization is present. Fun fact, the total precipitation globally in 1 calendar year, 5.52 thousand trillion tons of water a year. 5.52 thousand trillion tons of water a year falling from the sky from the water cycle. That is an immense amount. Alright, we're in the second half. We have 3 more terms to go, and they're some really good ones. This is going to sound weird, but I think this term has the win. It's wind. The movement of gas influenced by the atmosphere. A super crucial thing also for our weather in this planet. Wind is in really almost every planet in the solar system. Incredibly crucial. The movement of gas in the atmosphere driven by a difference in pressure. Without that difference in pressure, you don't have wind. High pressure versus low pressure. High pressure systems go up. When the wind blows frequently in a certain direction, it's called prevailing wind. We're going to have some more technical terms in this. Prevailing wind, so when like wind is usually like, let's say, pointing east for a long time, that's your eastern prevailing wind. And remember, wind is caused by that difference in pressure. When, like I said, wind always blows from a high pressure to a low pressure area, caused by the atmosphere, like different pressure, because the atmosphere, it tries to reach something called equilibrium all the time, that are perfectly balanced pressure every single time, trying to get it, like trying to go like not too high or not too low. It's never going to get there, but like with that altering of high and low pressure, it's going to be moving that gas, the wind, sweeping through the earth. The closer the differences in pressure are, so like if you're in an area with a lot of close difference between high and low pressure, the faster the wind will be. So if there's like not a giant difference in pressure, then there's going to be faster wind. If it's a big difference in pressure, not that much. Gales are called high force winds. So like the ones with really close temperature, really close pressure, those are gales. They can be up to 39 to 46 miles an hour, which is incredibly fast. Well, not for me. I don't know what incredibly fast is. Max wind here usually gets like 20 miles an hour, 25, not when it comes to like monsoons and stuff. But yeah, but sometimes it can get pretty windy here, and gales are those high force winds. Fun fact, the fastest ever recorded wind in the history of what we know, 318 miles an hour. That is faster than a Formula 1 race car. Wow, 319 miles an hour, caused by a tornado in Oklahoma in 1999, if you did not know that. But yeah, those tornadoes are usually the source of the super fast winds that we see really in Earth. Like usually the fastest winds are recorded not outside the tornado, but inside the tornado, but it's pretty hard to get there. Alright, 2 more terms to go. This term right here is not usually really loud, but it's interesting because it's cloud. Water vapor literally in the sky, literally right above us. Literally, as you can see, like the water I have here was one point in the sky, or suspended in the sky at one point, considering that we have the water cycle going on all the time. It is pushed around by wind, like we said, those differences in air pressure. Light reflected off of it. So like if you look at a cloud, you think, oh, nice fluffy white. You're wrong. Light reflected off of it makes it look nice and fluffy white, but it's actually really like dark gray and wet. So like when usually like you see a rainstorm come around, you can see like that dark gray wet, that dark gray clouds hovering over. That is the actual color of it, instead of like the white, because that's reflected light from the sun makes it look white, but it's actually kind of like wet and dark gray. We got 5 types. I'm going to move over here for this one because I'm going to listen out. The first one, cirrus. I think as I say it, cirrus. It's usually those icier clouds. It's more like wispy ones. There's like really thin, outstretched ones. Cumulus? Yeah, cumulus clouds. Those are the fluffy white ones you usually see everywhere. Cumulonimbus, those fluffy ones, but more darker and grayer. Nimbostratus, the thick ones, the super really thick ones. The ones, but they're also like dark color, like dark gray color, and more lower. So usually those ones, usually like the mountains, the ones that are like around rain. And the last one, stratus. Those are the thin, flat, and low ones. Those are usually the ones that we see up high. The cirrus ones are really high up because, like I said, they're icy and wispy. They're really like long and stretched out, and they can be pretty cold sometimes. And all of these clouds, everywhere, they form in the lowest level of the atmosphere, which we learned a bit ago was the troposphere, the lowest level of the atmosphere. Fun fact, the highest cloud is called the polar mesophoric. It's not like, but those are the 5 main types I said, but there's another one. It's called the polar mesophoric. It forms at 53 meters. It can be up to 53 meters, essentially. Remember that thing I called the fun fact that I told you about with the atmosphere, the Kármán line? The Kármán line is at 62. This is at 53. That's only 9. Yeah, it's only 9 miles off that Kármán line. So those polar mesophoric ones, pretty cold and wispy, because you get all the way up 53 miles up the sky. That's no easy feat. All right, one more term to go, and it's an interesting one. All right, one more term to go, and this one's an interesting one. Really kind of combines what we learned both in the last episode and this one into one term. We kind of touched on it in the last episode. The greenhouse effect. Ooh, the greenhouse effect, how it is being talked about so much in today's world. Stops the sun's energy from escaping into space. Essentially, remember, like, you know what an actual greenhouse is. The thing that they put, let me put a picture. This is an actual greenhouse. This is what they put plants in. Like a glass shed that traps all the heat to keep the plants warm and to give them more energy. That's essentially the same thing that's happening in the atmosphere with the greenhouse effect. All the sun's energy is being trapped into the atmosphere, not escaping into space, keeping us all nice, comfy, and warm. Carbon dioxide is the main contributor to the greenhouse effect, because carbon dioxide has a good ability to trap heat, and that's usually occurring in the higher atmosphere, contributing more heat and not letting heat escape into space, giving the planet more warmth. Usually right now, like in today's days, in today's world, it has a really negative connotation, the greenhouse effect, because it contributes to something called global warming, which is something we have seen and experienced all the time in the news, talking about like, oh, the greenhouse effect is bad. It's not really. It's a natural process of the Earth. Every planet has greenhouse effect, I think, or maybe just the Earth, maybe? Yeah. The greenhouse effect is a natural process, but is usually contributed with global warming, usually from the burning of fossil fuels, so like methane, carbon dioxide, nitrous oxide, water vapor, monoxide, sulfur dioxide. That all contributes. Those are all greenhouse gases, and those are the ones that go up into the sky and contribute to global warming, because those can trap in heat very easily. The more CO2 in the atmosphere, and more heat it traps, contributing to more different climate patterns. That's why people are so worried about global warming, and that's why we should need to try to solve this global warming issue. More heat is being trapped in the atmosphere, contributing to more different climate changes that can devastate other people around the world, causing bad patterns of weather to occur. Fun fact, by the year 2100, the global temperature could rise from 2.5 degrees, I think it's around 0.8 right now, from 2.5 degrees to 10.4 degrees if we don't stop this right now. If we don't stop trying to pollute the sky with the fossil fuels, it can rise up to 10.4 degrees by the year 2100. That is 88 years from now, which is still a lot. But yeah, hopefully in the future we can solve this. Alright, that's all the terms. Sadly, we don't have an experiment of the day today, but let's get right to announcements. We got some good ones. Oh, macro, almost knocked down the Statue of Liberty there. Well, interesting episode today. Announcements. Next episode of Season 4 is the final episode of Season 4 of Prietology. Season 4, Episode 6, coming to you at the beginning of next year. I'll announce the date probably in the next video of that, and maybe we'll see, or put in a community post. If you haven't seen, I've been posting community posts. I've been posting, I think the last post was post your new ideas. If you want new ideas, I'll probably post those once every 3 months, or maybe when I need ideas for next year. Yeah, so Season 4 finale next year, at the beginning of the year, probably in January. Get excited for that. Next week, opposed to every 2 weeks, is a new video. We're going to be playing an idle game, Overlord's New Mansion, coming to you on December 18th. The last video before the Dprieto Christmas special for this year, the 2022 Dprieto Christmas special. Get excited for that. But first, Overlord's New Mansion coming to you on December 18th, the same day as the World Cup finale. So yeah, get excited for both of those. I'm excited for Morocco, hopefully, to do well. Next episode, coming to you at the beginning of next year in 2023, is the theme, or the topic is, to close out the year, biomes. We are closing out 2020. We're closing out Season 4, Episode 5. Season 4, about geology, talking about biomes. So, the rainforest, the temperate lands, what even is a biome, the food web, deserts, abyss, open ocean, tundra, taiga, what even all this stuff. Even we'll talk about conservation to end the season. Well, everyone, thanks for watching. Hope this video was interesting. I will see you next week, remember, for Overlord's New Mansion, that game we'll try to play. So yeah, get excited for that, and I will see you next week. See ya, and
Well, hello everyone, welcome to 2023 and welcome back to Dprieto TV. We are already, wow, at 2023. Today's video, the final episode of Prietology Season 4, the grand finale of our geology and earth science. As you can see, we're still in the same place, have a brand new editing software as you can see. We have more effects, we have better video quality, so yeah, a lot of exciting things planned this year for 2023. And I'm glad you could join us for this first video of 2023. We got some big announcements at the end, so yeah, let's start this grand finale of Prietology Season 4. And today we're talking about ecosystems, so biomes, the tundra, the taiga, the food web, tropical rainforest, oceans, conservation we'll also talk about at the end. So yeah, get excited. So yeah, let's waste no more time. Let's go over the key terms. Alright, there we see we have 10 terms today. Good full episode for today for Prietology, the grand finale of Season 4. We're talking about biomes and the enchanting ecosystems today. So we got food web, biome, tundra, taiga, temperate forest, grassland, desert, tropical rainforest, ocean biomes, and conservation. Well, let's waste no more time and let's get started with our first term. Alright, here's our first term of our season finale, food web. Pretty simple term. Let's start off our enchanting ecosystems with this. It tracks which organisms that's a tongue twister. It tracks which organisms eat which organisms. So essentially it's like who eats who in the system, and the higher you go, the more of a predator they are. There's one for every ecosystem on the planet. So there's a desert one, there's one for the Arctic, for the temperate forest, for the tundra, for the taiga, for the rainforest. There's one for every one. And this food web is essentially tracks who eats who. It connects plants with animals. So usually at the bottom of almost every food web, plants are usually at the bottom of the food web. They get eaten and then they get eaten and then it just goes up to the top predator, the apex predator. Another way to look at it is to see how energy moves throughout an environment. So essentially what that means is that the plants produce their own energy through photosynthesis and stuff like that. They get eaten, their energy moves to the next animal, and then that animal that eats the plants gets eaten by another animal. That animal transfers its energy from the plants through there, and then when you get to the top, the animal that eats that animal eats the animal that ate the energy of the other animal, which got the energy from the plant. Hard to visualize it like that. But yeah, it shows how energy moves through a system. And like I said, plants are the base of the food web for mostly all the food webs out there. Sometimes for the oceans, those are more of like the plankton things, the little micro plankton people. So yeah, that's usually the base of food webs. Fun fact, let's see if I can say these names. V. Summerhays and C. Elton published the first food web in 1923. And now thinking about it, it's been 100 years since the food web was created. So happy 100-year anniversary to the food web. Now it's 2023. Alright, next term. This is going to be the bulk of our episode. Biome. Biomes is kind of like an umbrella for ecosystems. So it's like the umbrella, the region, the characterization that certain ecosystems have. Well, let's differentiate first biome and ecosystem. Ecosystem are all the plants, animals, and terrain and landforms. All the terrains and landforms in an area. So that's different from biome. Biomes are essentially the characterization of the groups of those ecosystems. The plants and animals in these biomes survive by adapting to its conditions. So if you're in a colder biome like the tundra that we'll talk about in the next term, you're going to want more colder fur. You're probably going to be more like adapted to a colder, more windier, not so much rain environment. And it's different than ecosystem in that it classifies certain similar ecosystems around the world. So places like the Americas, the Northeast Americas, and the Canada region, those are more of like a taiga, more like Arctic-y region. So those are kind of more of like a tundra taiga biome. And the thing with biomes, it depends mostly on climate and latitude. We talked about both of those in previous episodes, so go check it out. Here's the playlist up here. So yeah, it depends on climate, which is, like we said, like the average weather in an area, like we said last episode. So it's kind of like what is expected of the weather. And the latitude is essentially how far it is, so whether it's near the poles or the tropics or the equator. Fun fact, biomes in the Cape Floral region, which is in South Africa, have about 9,000 different plant species in the Cape Floral region. And that's in South Africa. 9,000 different plant species. Wow. All right. Third term. All right. Term number 3. This is where we start getting into our 1, 2, 3, 4, 5, 6, 7. We're talking about the 7 biggest biomes in the world. Here's our first one. The tundra. It is the world's coldest. It is absolutely freezing there. It's mostly found in high mountains, so the very high mountainy regions of the world, and ice caps, which we talked about in episode 4, which we talked about the waterworks and all the water formations that we have in our world. It's characterized by very short plants, so like not many plants around, and very short ones, so like little bits of grass, little scattered everywhere. That's what it is, and very short summers. Usually the summers there are pretty short. They only last like a couple months, and then after that it's back to cold sweeping winds. High winds, cold temperatures characterize this world's coldest biome. Yeah, not the easiest place to live in, considering if you live in the tundra. These can usually be found in the extremes of our latitude that we talked about, the poles and the higher tropics. So Antarctica, the Arctic, Russia, Siberia, that's also probably some, Canada, Greenland, those can get very, very, very cold and probably characterized in the tundra biome. Fun fact, the average annual temperature for the tundra biome is negative 14.8 degrees Fahrenheit. Annual average temperature. That is freezing. Absolutely freezing cold. And this is places like Greenland and Siberia and Canada. Places where if you go north enough, you can experience the tundra biome. Alright, this is essentially a lot of people join this and tundra together. Well, they're pretty similar, but let's talk about some of the differences. And this next term, our 4th term, taiga. It's probably a word you haven't heard that much. In the northern hemisphere, usually found south of the Arctic. So like in that Siberia, Canada region, that is where you could usually find Tonga. I mean, not Tonga. That's an island. Taiga. There you go. Also known as the boreal forest, if you've seen also that called, that is also the taiga biome. It's usually snowy. It's very snowy, very cold, and it's usually covered in something called fir conifer trees. Those are like your traditional pine cone trees that you see. Those are usually found in the taiga region. So places like Canada, Siberia, those are usually very foresty and very cold. Those are the taiga region. It's different than tundra because tundra doesn't have a lot of plants. It's the world's coldest. This is not the world's closest. It's pretty close. But taiga has more plants and more conifer trees, and tundra doesn't have that many plants, and it doesn't have fir conifer. It contains 1/3 of the Earth's trees. That is how many trees are in the taiga biome. It is full of trees, but at the same time, it has the fewest animal and plant species of any biome. Not many plants, not many animals, because it's pretty cold, pretty harsh weather, also pretty high winds. Fun fact about the taiga, it covers 17% of the Earth's land. More than 1/10 of the world is taiga, and that's considering the massiveness, and that's really considering the massiveness of Russia. It's huge. Siberia, it's a combination of tundra and taiga. Canada, northern Canada, has a lot of taiga and tundra. Greenland as well. Places like Norway and Sweden, yeah, a lot of the north, and usually found between south and the Arctic in the northern hemisphere. Alright, we are at our halfway point. Alright, this one is probably more closer to home than probably a lot of people. Temperate forest. If you live in places like New York, you've seen these temperate forests all the time. It's also known as the deciduous forest, or deciduous biome. The trees in the temperate forest change colors in the fall and lose their leaves in the autumn. So all those deciduous trees, the ones that change into pretty colors of red, orange, and yellow, those are deciduous trees, usually found south of the taiga. So you could think of like, you could think of the biomes as kind of like layers. Higher up you go, the more extreme. So it's like we have your tundra at the top, really at the really top of the earth near the poles. Then you have your taiga in between, and then you got your temperate forest, which is usually south of the taiga, and kind of has similar weather to this. 4 seasons, you got your 4 seasons. You got moderate summer, moderate spring, a bit of a harsher winter because you're near the taiga, and a moderate fall. Moderate climate is usually found in the temperate forest. That's why it's called temperate, like mild, like cool, like usually normal temperatures. It's not really that extreme. It's usually found, like I said, south in the taiga in places like North America, Europe as well. Northeast Asia is usually found in places like that, the taiga. And yeah, and it's usually found like places like that where temperate forest and the climate is usually good for the temperate forest to exist. Fun fact, the temperate forest is home to the giant redwood tree, which is the tallest tree in the world. It's usually found in like the California redwoods, Oregon, Northern California, Washington, that area. That is also a lot of temperate forest as well, which have a moderate climate. So these giant redwoods are able to grow pretty tall. Alright, this is also can be found in North America. We're essentially going down from the poles. So we touched the tundra, the taiga, the temperate forest. We're going to go down a little bit more. The grasslands, wide open spaces across the world. They have been found everywhere across the world. We know here in the U.S. as the Great Plains, but they have multiple names. They can be either known as pampas, like in South America, prairies, like here in the U.S. Veld, I've never heard it called veld before. I don't know where that is. The savanna, the Great Serengeti in Africa, and the steppes in eastern Russia and places like that. Multiple names. Medium climate, so kind of like back to our temperate forest. Dry, really kind of like medium dry. You get some rain and medium rain, like I said. So kind of like medium dry, medium rain, but there's still large grasses, large open areas. It's usually, like I said, between the desert and the forest, and that gives us a hint to our next term. So, like I said, you got your tundra, then your taiga, then your temperate forest, and now you got your grasslands. So that's usually between the grasslands and the desert. A temperate grassland, it's a combination, you could say, of the temperate forest and the grasslands, has almost no trees. If you think of something like the Serengeti, the Great Savannas of Africa, you have large grasslands, but you do still have some trees. Temperate grasslands, almost no trees at all. Fun fact, the height of the tallest grasses in some of the grasslands of the world can be up to 6.5 feet. That is massive. That is, how much is 6.5 feet? I'm trying to look around my room. 6.5 feet is probably the height of the shelf that you see over here of my Lego architectures. It's probably the height of the shelf, so imagine that. That's a very, very, very tall grass. You could also think of the biomes that we've talked about as like a spectrum. So we have our next term here, desert, which is a very, 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 very dry climate. Almost gets no rain at all, and when it rains hard. Like here in Phoenix, I'm in the middle of a desert. When it rains here, usually in the summer, it rains hard. It all comes down at once in a giant monsoon with wind, thunder, lightning, sometimes hail if it's an extreme case. And it's usually very dry, these deserts, and they're made of sand, rock, and gravel. Very, very dusted and arid. That is a key term you want to know. Arid, which means not many rainfall, and very dry as well. It can either be extreme cold or extreme heat, or extreme cold, however you want it. Same thing. Hotter deserts like the Sahara, what's the one in the U.S., Mexico, the Sedona? Yeah, like places like that, like the Sahara. Well, the Sahara really is the big one. Those are really usually hotter deserts and are closer to the equator. Our colder deserts, like the Gobi, Antarctica is a desert. It's a cold desert, very, very, very cold, are going to be closer to the poles. So if you think about, like I said at the beginning of this term, think of the biomes as a spectrum. You got your tundra, incredibly, incredibly cold. Your desert, usually very incredibly, incredibly hot. And then you got your temperate grasslands. And in the middle, you have your temperate forest. Essentially, the basics of it all. The Goldilocks zone of the temperate, of the biomes. Very in the middle and very temperate everything. So you can think of tundra and the desert as the extremes. And then taiga and grassland kind of like in the middle. So not as hot, not as cold, but temperate forest is just right. Fun fact, the biggest desert in the world is Sahara in North Africa. 3.5 million square miles of land it takes up in North Africa. That is a huge amount. And the Sahel, where is the border between North Africa, the Sahara, and down below near South Africa, everywhere below the desert, that is also included. That area is called the Sahel, I think, if it's called. Yeah, 3.5 million square miles of land. That is a massive amount. Alright, we are on term number 8. We are almost done with season 4 of Prietology. Wow, we are already 4 seasons done. This is an interesting term. It doesn't really fall into our spectrum. This is kind of like an outlier. Tropical rainforest. There you go. I said it right. Tropical rainforest, very wet and very humid and very warm. Not as hot as the desert, but a warm, humid, and wet climate. You know them everywhere in the world. Mostly you can find them in South America, like the Amazon. Lots of colors. It's very, very, very colorful. Very colorful environment with lots of plants and animals. The most in any other biome. It has more plants and animals than any other biome. Does not have regular seasons, so you don't have your summer, fall, winter, and spring there. It usually has wet and dry seasons. The wet seasons you could obviously think are in the summer, more summery things. So those are more like rain, more humid, more wet. And the dry seasons, not that dry. It's not like dry like here in the desert dry. It usually dries and like doesn't fall that much rain, but it's very, very, very short. And after that, it comes back with the water and wet rain, and wet season is back again. Fun fact, the rainforest land in the world, global rainforest land, has dropped from 14%. 14% of the world used to be rainforest now, to 6%. That is massive. That is an 8%. That is an 8% difference of the amount of rainforest land that we have in the world. That is a bad thing. We need to stop like cutting down the rainforest and using them as things in deforestation. That is the main cause of rainforests being destroyed today. We're going to lose all the diverse creatures and diverse plants that we have in the rainforest. But yeah, wet and humid climate. Let's go to something that probably even is more wet. In the next term, our penultimate term. All right. Our penultimate term of season 4. Wow. Let's get on to it. This is an interesting one. This also doesn't fall into our spectrum because it's essentially around the spectrum. It surrounds the spectrum. The ocean biomes. There's 3 of them. I should make that plural. Ocean biomes. There are 3 types that we'll be talking about. The 3 big types, the 3 only types in the world. The open ocean, the deep sea, and the coral reef. Yes, the coral reef has its own biome. I'll explain why. First, we'll talk about the open ocean. Vast water. The biggest biome in the world and covers most of the earth. Vast waters everywhere. And most of the plants and creatures that live in there live in the sunlit area, the places where light is still visible. And this includes most phytoplankton, which is a lot of the diet that most of these plants based on. And like I said at the beginning of the episode, when I was talking about the food web, phytoplankton in the oceans is the base of the food web, and all the plants and animals, eat it, and then it goes up and transfers its energy up the food chain. The deep sea, which we will now talk about, the strangest ecosystem, the strangest of the biomes, no sunlight, freezing temperatures of water, immense pressure, the same pressure of going 2 kilometers underneath the ocean. It is crushing temperature. So yeah, those are really a lot of strange creatures. Bioluminescence, the phenomenon that is very well known in the deep sea. Bacteria in certain fish, glowing to make them glow in spooky and colorful colors in the ocean to help them hunt prey and like lure the prey, and then they just hunt them and then they get eaten. Yeah. And then our final one, the coral reef, made of coral, which you didn't know, is made of the exoskeletons of living creatures. So essentially calcium. Calcium is a big thing that's made of coral. Very colorful. Lots of like smaller creatures, lots of like things like eels and small fish. Sometimes sharks go there and prey for them and hunt for food there. And usually found the coral reef in the sunlit zone. Fun fact about the ocean biomes. Point Nemo, which is in the Pacific Ocean, it's a point on the Pacific Ocean called Point Nemo, is the farthest point from land in the world. So everywhere in the world, Point Nemo is incredibly far from land. 1,670 miles from land. That land is essentially like 16700. That is the farthest you can go from land in the world. It is very, very far. Alright, one more term, everyone. One more term to end Prietology Season 4. It all comes down to this. The final term of Prietology Season 4. Conservation. I know, that's a weird one to end it, but conservation, a movement to protect ecosystems and biomes. And not just that, other landforms as well. Plants, animals, to preserve them in every single biome in the world. Also to protect waterways and waterworks, the waterworks like we talked about, landforms as well, to keep the knowledge of biomes still alive. Essentially, this is the people who protect the ecosystems and organizations that protect the ecosystems. Tries to fight things like deforestation, the deforestation like I talked about with the tropical rainforest, that they're being diminished in size by 8%. Climate change as well, pollution of our ecosystems and our precious, our enchanting ecosystems, like our episode is called in our biome. Pollution is getting into our precious biomes, people. We need to fight them. And climate change as well, affecting the biomes and the plants and animals that live in them. Conservation is a hugely debated topic nowadays with all the politics stuff happening in the world. So yeah, protect conservation. Let's keep conserving our planet, and let's conserve our waterworks, our landforms, our plants and animals, our tundras and taigas and temperate forests and grasslands and deserts and ocean biomes and tropical rainforests. Let's conserve all this so we can enjoy it in the future. Alright, the final fun fact of Season 4. The WWF, not the World Wrestling Federation, and there's a lawsuit about that later. The World Wildlife Fund, I'll put a picture of it up here. The World Wildlife Fund, the largest conservation organization in the world, is fighting all this to continue all this. Over 5 million members are part of the World Wildlife Fund. I don't know how to be part of it, but yeah. That'd be a cool thing to part of. So if you guys know how to be a part of the World Wildlife Fund, do it. It's a great organization with a great cause. That's it. That's all the terms in Season 4. Well, that's it, everyone. Thanks, guys, for enjoying Season 4 of Prietology. Let's get on to the outro to say our final goodbyes to Season 4 of Prietology. That's it, everyone. Prietology Season 4 is a wrap. We're done talking about geology and earth science. Thank you guys so much for being with us this entire season. 6 amazing episodes. We talked about the formation of the earth, the core, the rocks, minerals, latitude and longitude, and how they actually work. Landforms like mountains, canyons, lakes, and like we talked about in the waterworks, lakes, rivers, deltas. We talked about weather, what is climate, weather, precipitation, and then today we talked about biomes, the food web, the tundra, grasslands, and conservation, how we can protect everything that we've talked about in this season and hope to better it for the future. Oh, okay, my light turned on. Alright, so yeah, this is the last episode of Season 4. Some more announcements. Formula 1 2021, we're back to playing it again. That's the next video, coming on January 29th. It's a bit outdated, of course, 2021 was 2 years ago, but still, it's a great game to play. We'll be back to playing it on January 29th. Now, this is where it gets a bit heavy. Next season, Season 5 of Prietology, will be the last ever season. That's it. Next season will be the last season of Prietology I will be making on Dprieto TV. Be with us for the entire thing. We got, I think, a lot of episodes. We got about 7 episodes. It's going to be the grand finale of Prietology. Everything, this all started 3 years ago in 2020 because of the pandemic. We've talked about chemistry. We've talked about physics, biology, earth science, and geology. And now, to round out the series of Prietology, Season 5 will be about... I'm going to do an extended drum roll. We're heading and we're reaching for the stars. We're going to talk about astronomy. Astronomy, the solar system, constellations, supernovas, the space-time, dark matter, the theory of relativity, stuff like that. Stars, what is a star? The asteroid belt. We got a lot of interesting things to talk about in Season 5 of Prietology. We're reaching for the stars. Astronomy is our topic, something I'm very passionate about. This Season 5 will probably be coming, not for a while, it'll probably be coming at the end of the summer maybe, and we'll do it entirety. We'll probably focus of it on the entirety of the rest of 2023. So get excited for that. Prietology Season 5. Well, everyone, thank you for watching. Thank you for being with us for another season of Prietology. It's been great having the time here. It's been great having the little Statue of Liberty, the little minor statue, my plasma globe here. So yeah, thanks to this season of Prietology, and hope to see you for the next one, Season 5, coming in the late summer. And see you next week for F1 2021. See ya.